Hi, hello students. Good evening everyone. I hope all are doing well. Anyway, warm welcome all of you to the Infinity Learn JEE YouTube channel. This is me Surya, your chemistry faculty from Infinity Learn. Okay, fine. Today we are moving to the fourth part of our same chapter, that is thermodynamics. In the previous session we have discussed about the laws of thermodynamics, right? So we will starting from the zeroth law of thermodynamics. Then we studied about the first law of thermodynamics. In today's session, we will be discussing about the second law of thermodynamics. We will be discussing about the new subtopics like entropy, Gibbs free energy, and so on. Ready? Okay. Before entering into this session, you must have an idea about what you mean by spontaneity or the spontaneous process, right? Is there any idea about the spontaneous process? What do you mean by spontaneous process? Yes. Spontaneous means this is the process which may take place by itself, right? There is no any other external agencies required. By itself, whenever the process is taking place, that type of process are known as spontaneous process, right? So we can take some examples like that. Movement of water, right? Flow of water from high level to low level. There is no need of any energy, right? Generally, the water will flow from high level to low level. And similarly, the heat will move from high temperature to low temperature, right? High temperature to low temperature, there is no need of any energy. Flow of heat will happens. Such type of process is known as spontaneous. There is no need of any energy. Right? Just opposite that, we will be studying about the non-spontaneous process, which means that there requires some force, right? Some force or some external agency is required for the non-spontaneous process to be happen. So we can say that a process, if it cannot take place by its own, right, by its own, is known as a non-spontaneous process. Otherwise, it is also known as non-feasible process. Again, the example is like the flow of water from lower level to high level, right? Whenever we are pumping water from our well to pump, right, it will require some motor or external force will be required. Similarly, the flow of heat from a cold body to hot body again require an external force or external agency, right? Such type of processes are known as spontaneous as well as non-spontaneous process. Clear? Now, in the case of thermodynamics, we will be explaining about what is the condition for spontaneity or the spontaneous process. To become a process spontaneous, what are the major conditions? As you can see over here, the overall tendency for a process to be spontaneous will depends upon the two factors. One is the minimum energy, right? One is the tendency for minimum energy, and the another one is the tendency for maximum randomness. Tendency for minimum energy as well as tendency for maximum randomness. So we will be introducing two different terms here. The first one, it is the Gibbs free energy. Then next term is the entropy. These two terms will depend on the process whether it will become spontaneous or non-spontaneous, right? So let's start with the first term, that is the entropy. Okay. What do you mean by entropy? We can define the entropy as it is the degree of disorderness, right? Degree of disorderness or the randomness of the system. For example, if you are keeping the books in a library, right, it will be well ordered manner, which means that their entropy is very high, right? Degree of disorderness is very slow, so entropy is very high. So here the entropy can be denoted by the letter capital S. Then again, we know about the extensive properties and state functions, right? State functions means it depends on final and initial state. So we can find out the change in entropy as delta S is equal to S2 minus S1, right? S2 minus S1, which will be the change because it is a state function. Then what about the extensive property? This depends on the amount of substance, right? Depends on amount of substance. So again, entropy is also an extensive property. Right. Now, whenever we are considering the states of matter, three states are present, right? Generally, solid, liquid and gas. Whenever we are considering the solid, liquid and gas, there will be the order of entropy like this. For example, if I am taking a solid particle, right? If I am taking a solid particle here, just assume this is a solid particle. Okay, this will be the gas particle, right? So, by the picture itself, you can identify that what will be the order, right? Order of particles here. Here in the case of solid state, it will be well arranged, right? Degree of disorderness is very high here. So we can say that entropy for a solid substance is maximum, but for a gas substance it is minimum, right? So we can find out the order for entropies here like that. Solid has the maximum, then liquid, then gas, right? Because the arrangement of particles is different here. In the case of solid particle, the molecules are well orderly arranged. So degree of disorderness is maximum here. So we can say that, degree of disorderness is minimum here. Yes. Degree of disorderness is minimum here in the case of solid particle, right? Well orderly arranged. Then liquid, then gas. Clear? This is the order given here. The entropy of gas is maximum as compared to the liquid than the solid. Now, in order to find out the calculation, right, numerical problems, there will be a formula for calculating the entropy, that is equal to delta S is equal to Q reversible by temperature, where Q is the heat exchange, then T is the temperature in Kelvin. T is the temperature in Kelvin, right? In the case of heat, general unit is joule, right? Joule. For temperature, it is Kelvin. Therefore, the unit for entropy is taken as joule per Kelvin or joule Kelvin inverse. Now in the starting, we have studied about the different types of thermodynamic process, right? Starting from isothermal, adiabatic, isobaric and isochoric. Similarly, you can find out the entropy change for different processes also. For example, if I am taking first case, I am taking the isothermal process, right? Isothermal process. In general, the entropy is equal to Q reversible by temperature, right? Here the temperature is constant. So we are taking here delta S is equal to Q reversible by temperature, right? Q reversible by temperature. Then, according to the first law of thermodynamics, we know that isothermal condition, right? Delta T is equal to 0. Therefore, delta U is also equal to 0, which means that Q is equal to the negative of work done, right? Negative of work done. We have studied that the work done is equal to minus 2.303. Work done is equal to minus 2.303 nRT log V2 by V1, right? V2 means the final volume, then V1 is the initial volume. So, that is the work done, negative of 2.303 nRT log V2 by V1. We are taking the negative of the same work done, right, which will be the heat given here, that is Q reversible. Then it will become 2.303 nRT log V2 by V1 whole divided by T, it will equal to 2.303 nr, where t get cancelled, right? nr log V2 by V1. This will be the formula to calculate the entropy change in a reversible isothermal process. Reversible isothermal process. Clear? Similarly, we can find out the adiabatic process also. In the case of adiabatic process, right, there will not be any heat exchange, which means that Q reversible or Q is equal to 0. So we can say that simply delta S is equal to 0, right? 0 by temperature 0, that will be 0. Then third one, right? Isobaric process, which means process take place at the constant pressure condition, delta P is equal to 0. So for that, delta is equal to Q reversible by temperature. While taking here, you will get the answer around NCP log T2 by T1. NCP log T2 by T1. Where Cp is the heat capacity at constant pressure. Last one, it is the isochoric process, right? The process which takes place at constant volume, that is delta V is equal to 0. For that, entropy change is equal to NCV log T2 by T1. T2 is the final temperature and T1 is the initial temperature, where Cv is the heat capacity at constant volume. These are the 4 important formulas you have to keep in mind to solve the numerical problems related to entropy change for different, that is for thermodynamic process. Now, while introducing about the entropy, we will be moving to the second law of thermodynamics. Before that, you must have an idea about what will be the entropy change for system as well as surroundings, right? So, we already know about what you mean by system and surrounding. So, if I am taking a system here, right, this will be the system having a temperature of T1. Then another one, it is the surroundings, right? For example, if I am taking any of the surroundings here, this will be the system. I am assuming here this is the surrounding. So I can say that T2 will be the temperature of surroundings. So T1 is always greater than T2. So that heat will change from here to here, right? System to surroundings, heat is changing. Q is changing here, which means that system is losing heat and surrounding is absorbing the same heat. So we can say that the delta S of the system, right? Delta S, which means the change in entropy of the system is equal to system is losing heat, right? System is losing heat, which means that minus Q reversible divided by temperature T1, right? This will be the first condition. Now, the second condition, we have to find out the change in entropy for the surroundings. So it will be equal to delta S surroundings. Delta S surroundings is equal to plus Q, which means surrounding is absorbing heat from the system, plus Q reversible divided by temperature will be T2, right? Q reversible by T2. Now we have to find out the entropy change in the universe, which means that it will be the sum of delta S system and the delta S surrounding, right? So I am taking here delta S system. So delta S universe is equal to, first one, minus Q reversible by T1, right? Plus Q reversible divided by T2. So I am taking here Q reversible outside, right? Q reversible outside. It will become minus 1 by T1 plus 1 by T2. right? This will be the final equation for the delta S for the universe, that is equal to Q reversible into T1 minus T2 divided by T1 T2, where T1 is always greater than T2, right? Which means that this term will always be positive. This will be always positive, right? This will be the term that will be always positive. That will introduces our second law of thermodynamics, which means that entropy of universe is always increase in every spontaneous process, which means that delta S universe is always greater than 0. That is positive, right? Clear? Hi Aryan, good evening. Okay, we have just discussed about the entropy, right? Just discussed about the entropy changes. Then we will be moving to the second law of thermodynamics. And the entropy, right? Entropy is the degree of disorderness, right? A degree of disorderness or the randomness of the molecule. It is denoted by the S. And there is a order of different molecule, right? If we are taking gas, liquid and solid, this will be the entropy order starting from solid, liquid and gas has the maximum entropy. Then we will be studying about the entropy change for the particular process, right? General expression for finding entropy change is Q reversible by temperature. So these are the important formula you have to be keep in mind to solve the problems. That is isothermal process, it is 2.303 nr log V2 by V1. Then for adiabatic, obviously it will be 0. For isobaric it is equal to NCP log T2 by T1. Then for isochoric it is NCV log T2 by T1. Then we will be introducing our second law of thermodynamics, which states that entropy of universe is always increasing every spontaneous process. Okay, I hope it was clear for Aryang. That's why I'm repeating the same thing. Okay, so far we have discussed about the second law of thermodynamics, right? So depending upon the sign of entropy, we can predict whether the process is spontaneous or not. For example, if I am telling that delta S of the universe, right? Okay, fine. Okay, delta S of the universe or the delta S total, if it is getting positive, right? If it is getting positive means S2 minus S1 is equal to positive, right? Which means that entropy increases. So we can say that the particular process is spontaneous in nature. Then what about the next one? If it is not non-spontaneous, we can say that the delta S of the universe or delta S total is equal to negative, right? These are the important signs you have to be keep in mind. Hi Tayasa Sharma. Then what about the equilibrium condition? In the equilibrium condition, the delta S or the change in entropy for the universe will be keep it as 0, right? Delta S total is equal to 0, which means that the sum of delta S system and the surroundings will be 0. Clear? Yes, fine. Now, whenever we are discussing about the spontaneity or the spontaneous for a process, we will be discussing two terms, right? First one, it is the minimum energy, and second one is the maximum randomness. The randomness is related with the entropy. Now we will be discussing about the energy change, right? Energy change. The particular term is known as Gibbs free energy. Pradhan, which example? Okay, we will be discussing about the Gibbs free energy here. Gibbs free energy is defined as the maximum amount of energy, right? Maximum amount of available energy that can be converted to useful work. Is known as the Gibbs free energy. Again, obviously it is also an extensive property which depends on the amount of substance. Then again, state function, right? We can find out the value, change in Gibbs free energy by taking the value of delta G is equal to G2 minus G1, right? It is a state function, right? State function, which means depends on initial and final state. Now, the Gibbs free energy change depends on the terms enthalpy, right? We have already discussed in the previous session. Then temperature and now we are discussing about the term entropy. So we can define a formula to calculate the problem like G is equal to H minus Ts. G is the Gibbs free energy, H is the enthalpy, T is the temperature, and S is the entropy, right? Now we will be modifying this formula like that. Change in Gibbs free energy, delta G is equal to change in enthalpy, delta H minus T into delta S, where delta S is the change in entropy. This particular formula or particular equation is known as Gibbs equation. Gibbs equation. Based on this particular equation, you will get more problems in JEE Main exams. Clear? We have already discussed about the entropy change, right? Whenever we are taking any spontaneous process, we can say that the delta S of universe or the delta S total is always positive. In terms of Gibbs free energy change also, we can predict whether the process is spontaneous or not. This is a simple derivation to find out the spontaneity in terms of Gibbs free energy. Just go through it. You will get an idea about how it is getting, right? Clear? Okay. This is the first term. We already know the delta S of universe, right? The change in entropy for universe is equal to the sum of delta S for system and surrounding. This will be our first equation, right? Then, if heat QP, right? If heat QP is lost by the surroundings and gained by the system, then we can term that delta S surroundings, right? Which means that the heat is lost by the surroundings. We will take this heat as minus Q. Any doubt? Which is in the constant pressure condition. So I am taking here QP. So delta S surroundings is equal to minus QP divided by T, where T is the temperature. This will be the second equation, right? Then in the previous session we have discussed about that the heat exchange, right? Heat exchange in the constant pressure condition will be equal to the delta S, right? Delta S system, or we can say that here system is gaining heat, right? System is gaining heat. So we can take it as plus QP, right? Plus QP. Any doubt? Here system is lost energy, so it is taking minus QP in terms of surroundings. For system it will be gaining, so it is taking plus QP. So I can say that this QP I will be taking it as delta S system. Then what will happen to this particular equation? The second equation, we can write it as delta S surrounding is equal to minus of delta S system divided by temperature, right? Because it is the QP term, QP I can equate with the delta S system. Then it will become delta S of surrounding is equal to minus of delta S system divided by temperature. This will be our third equation. Then, now I am substituting the particular equation to the first equation, that is delta S total is equal to delta S system plus delta S surrounding. Then you will get that delta S system plus delta S surrounding is equal to minus of delta S system by temperature, right? Delta S system by temperature. Now, in order to modify this equation, I will just multiply this whole equation by temperature, right? What will happen here? I multiply it with temperature, right? T into delta S total. Then delta S system into temperature, right? T into delta S system minus T into delta S system divided by T, which means T get cancelled, right? So final equation you will get, right? T delta S total is equal to T delta S system minus delta S system. This will be your fifth equation, right? Clear? Now you have studied about delta G is equal to delta H minus T delta S, right? Delta G is equal to delta H minus T delta S. If I multiply the complete equation by minus 1, what will the equation become? Minus delta G is equal to minus delta H plus T delta S, right? Or similarly, I can written this equation as minus of delta G is equal to T delta S minus delta S, right? So I am rewriting the equation here. This is T delta S system minus delta S system. That is rewriting as minus of delta G system, which is the change in Gibbs free energy for the system. Right? Clear? Now in order to predict the in terms of Gibbs free energy, I am just rearranging the equation. It will become delta G system, which means change in Gibbs free energy of system is equal to the negative of product of temperature and the delta S of the universe. Right? Clear? This will be a simple derivation to calculate the delta G system in terms of temperature and spontaneity. I mean entropy. Hi Ayeshu. Okay, in final after derivation you will get the formula like this. Delta G system is equal to minus T delta S total, right? Where T delta S total or delta S total is the entropy change for the universe. Now, if I am taking delta S positive, right? We know that in the case of spontaneous process, the change in entropy will be always positive, right? Always positive, which means that delta S total is positive, right? Now, focus on this equation only. Delta S total will be positive, right? For a spontaneous process. Then what will be the value of delta G? Whether it is positive or negative. For a spontaneous process, delta S total is positive, right? No doubt. Delta S will be always positive for a spontaneous process. Then what will be the sign of delta G? Sign of delta G in terms of spontaneous process. Okay, this will be positive, right? Delta S is positive. If I multiply negative with positive, it will become, the final will become negative. So I can say that for a spontaneous process, the delta G system will be negative, right? Clear? Delta G system will be negative for a spontaneous process. Is the thing clear? Just let me know. Yes, fine. Okay, then what about the non-spontaneous process? In terms of entropy, we know that in the case of non-spontaneous process also, delta S will be negative, right? Delta S will be negative, no doubt. So focusing this equation, you will get this term will be negative, right? When I multiply negative temperature into negative delta S, it will become positive, right? It will become positive. So which means that delta G system or the change in Gibbs free energy for a system in the non-spontaneous process is always positive. Always positive, right? In the last condition, we will be discussing about the equilibrium, right? In the case of equilibrium, delta S is equal to 0, right? Delta S is equal to 0, which means that delta G system is also 0 for an equilibrium process, right? Okay, based on this idea, we will get more questions. In order to find out the temperature, apply the formula, Gibbs equation, applying the different values of delta G. In the case of Gibbs equation, you will get the numerical problems, right? Clear? Now, whenever we are discussing about the Gibbs equation, right? Okay, in the case of Gibbs equation, we know that it is equal to delta G is equal to delta H minus T delta S, right? delta H is equal to delta H minus T delta S. This will be our Gibbs free equation, right? We have already predicted the spontaneity of a process in terms of Gibbs free energy, right? In terms of Gibbs free energy, we have already discussed. In terms of enthalpy also we have discussed in the earlier classes. Then in terms of entropy also it is done. Then the remaining part is the temperature, right? Remaining part is the temperature. So we have to predict the effect of temperature in the case of a spontaneity of process, right? Ready? It will be a little bit confusing. Please give the complete attention here. Yes, fine. Now, first case I am taking here, delta H is negative. You must give me the formula for the delta G. Okay, if I am taking delta H negative, right, delta H will be negative. Then delta S is positive, right, delta S is positive. I am taking here delta S is positive, right. Then what will be the delta G value? What will be the delta G value? Delta H is negative, delta S is positive. Then what will be the delta G value? It will be negative, right? It will be negative. Otherwise, you can remember like this. In the case of a spontaneous process, right, delta G should be negative. Delta G should be negative for a spontaneous process. Then what about delta S? It should be positive, right? Then delta H, it should be negative, which means that in the case of this particular condition, we can say that this process is spontaneous at all temperatures, right? It is spontaneous at all temperatures. Now here arising the different condition, right? Now I am taking the second condition. If I am taking delta H positive, right? Delta H positive. From the delta H onwards, you will get an idea that the process may be non-spontaneous, right? The process may be non-spontaneous. So I am taking here, what will be the change here in the case of delta G? Delta H is positive, so I can take it as delta H. Then delta S is negative, right? Delta S is negative, so I am multiplying here with minus into minus, or negative into negative, it will become positive, right? So I am rewriting this particular equation as delta H plus T delta S, right? Are you getting my point? Delta G is equal to delta H plus T delta S for a second condition, right? Positive and negative delta H and delta S value. Then I have a question for you. In order to make this particular process spontaneous, right, what will be the condition? Okay, what will be the condition? I want to get this delta G value negative. So I can say that delta H plus T delta H should be negative, which means that okay, wait. What will be the value here? For example, here I am taking first condition, right? Delta G will be positive, right? So that it will become non-spontaneous, first condition. It will become non-spontaneous, which means that at all temperature it will be non-spontaneous, right? At all temperature it will be non-spontaneous. Whether using formula or you can just calculating here like that. In the case of delta H negative, the process will be spontaneous. If it is taking positive, it will become non-spontaneous, right? Clear? Now the third condition, I am taking here delta H is equal to positive, and delta S is equal to positive. How this Gibbs equation will change? How this Gibbs equation will change? Delta H is positive and delta S is positive. The general Gibbs equation, right? It will equal to delta G is equal to delta H minus T delta S. In order to make this process spontaneous, I am saying like that it will be negative, right? It will be negative for a spontaneous process, which means that in order to make this value negative, I can say that delta H should be less than as compared to T delta S, right? Delta H should be less than as compared to T delta S, which means that this process is spontaneous. This process is spontaneous at high temperature, which means that we cannot change the delta S here. It is already fixed as positive. So if I am taking temperature here, I can say that we can make this delta G value to the negative value by changing temperature to high temperature. Clear? By changing the temperature into high temperature. So I can say that whenever our delta H and delta S values are positive, then the process will become spontaneous at high temperature, right? At high temperature, which means T is increasing. Clear? Then what about the last condition? If I am taking delta H is equal to negative, right? So it will be minus delta H. Then again delta S is also negative, so I am taking here plus T delta S, right? Plus T delta S, or I can written it as T delta S minus delta H, right? In order to make the process spontaneous, I am saying like that delta G should be negative. So I can say that right, T delta S should be less than delta H, which means that delta S is fixed and delta H is fixed. We can change the temperature only, which means that at very low temperature, right? At very low temperature, this process is spontaneous. Clear? Are you getting my point? Okay, no need to memorize the complete table. If you have the idea about the delta H and delta S value, you can just put it in the Gibbs equation, right? So you can get the values of modified Gibbs equation. From that you can identify whether it is spontaneous at which temperature, whether it is at the high temperature or low temperature. Clear? Yes, fine. Now we will be moving to the practice question. The first question it is based on the Gibbs equation. Here the question given that at 0 degrees Celsius, ice and water are in equilibrium. Ice and water are in equilibrium and the delta H is given as 6 kilojoule. 6 kilojoule. What will be the value of delta S here? Change in entropy. Okay, give me the answers in comment box. Options are given here. Just calculate. It is based on the Gibbs equation. And the condition is given here, ice and water at the equilibrium condition. You have to find out the temperature here. You have to find, temperature is also given here. You have to find out the change in entropy, delta S. right? Temperature is already given here. It is equal to 0 degrees Celsius. I am converting it into the SI unit, that is Kelvin, that is equal to 273 Kelvin. Then here enthalpy is given in kilojoule. We have to convert it into joule. I am multiplying with 10 to the power 3 or 1000. Then there is a condition given that it is at the equilibrium condition, right? For equilibrium condition, okay, for equilibrium condition, we are taking delta G is equal to 0. By applying the Gibbs free equation, you will get a formula like this. Delta H is equal to T delta S, or delta S can be calculated by taking the division, right? Delta H by T. You will get an answer around approximately 21.9, right? 21.9. Then the approximate answer is given here. It is 22 joule Kelvin inverse mole inverse, which means option 1 will be the correct answer. Clear? Yes, Anil, you are correct. First one is the correct answer here. Hi Krishang. Now here is the next question for you. Again, based on the Gibbs equation, the enthalpy and entropy change for a particular reaction Br2 plus Cl2 gives 2 BrCl is given, that is 30 kilojoule per mole and 105 joule Kelvin inverse mole inverse respectively. At the equilibrium condition, what will be the temperature? How we can approach this question? First, you have to read the question carefully. There will be some unit conversions, right? Generally, you will be taking all the values in their SI units only. Here you can see that the enthalpy change, right? Delta H is given that it is equal to kilojoule. You have to be converted into the joule, right? Then entropy is also given here. Delta S is equal to 105 joule Kelvin inverse mole inverse, right? Then condition is given that at equilibrium, right? At equilibrium, yes, equilibrium, which means that delta G is equal to 0. Therefore, our Gibbs equation will become delta H is equal to T delta S, or you can get temperature is equal to delta H by delta S, right? Delta H by delta S. What will be the answer? You can just calculate. It will approximately equal to 285.7 Kelvin, which means that option A will be the correct answer. Clear? Okay, if you are aware with the formula, just calculate the particular numerical problem by using the formula. The important point you have to be noted that there will be some unit conversions, right? Now here is the next question. It is based on the spontaneity. An equilibrium reaction X plus Y gives W plus Z, given delta H is equal to positive, right? Delta H is equal to positive. That is spontaneous in the forward direction. Spontaneous in the forward reaction. Then corresponding sign for delta G and delta S should be respectively. We have studied the table, right? What will be the condition for delta G and delta S if delta H is given? What will be the answer? No need to memorize the complete table, just apply it on the Gibbs equation. Delta G is equal to delta H minus T delta S. delta H is positive, right? So I am taking here delta H. In order to make the process spontaneous, delta G will be negative, right? Delta G is negative here, delta H is positive here. While applying this equation, you will get that delta S will be positive, right? Which means option 2 will be the correct answer. Delta G will be negative and delta S will be positive. Clear? Again, here is the last question from this session. Based on the Gibbs free equation, find out the spontaneity. And also, the question is the dissolution of ammonium chloride, right? Dissolution of ammonium chloride in water is an endothermic reaction, right? Whenever we are discussing about the enthalpy, we have studied about the sign for enthalpy for an endothermic and exothermic reaction. So you must have an idea about that. Then it is spontaneous because what will be the condition? If I am considering the process as endothermic, right, what will be the sign of enthalpy change, delta H, whether it is positive or negative? Positive, right? So this is the endothermic process. Heat is absorbing here, so delta H is equal to positive. Now apply the Gibbs equation. Delta G is equal to delta H minus T delta S. Condition is given that the process is spontaneous, which means that delta G should be negative, right? Delta G should be negative. Then delta H is positive here. So the equation will be same in this particular case also. So in order to make this delta G value negative, I can say that delta H should be less than T delta S, right? Delta H should be less than T delta S, right? Any doubt? Delta H should be less than T delta S, which means that the process is spontaneous at high temperature only. So you can see that option 4, right? Yes, option 4 will be the correct answer here. Delta H is positive because it is a endothermic reaction. Then in order to make the delta G value negative, you will make this term delta H is less than T delta S. Option 4 will be the correct answer. Clear? Okay, that's all about from my side for today. We have discussed about the laws of thermodynamics. The previous session we have started from the 0th law of thermodynamics. Then we studied about the first law of thermodynamics. In this particular session, we have covered about the second law of thermodynamics, including the new terms like entropy and Gibbs free energy exchange, right? Delta G. So we have studied about one more important equation, that is the Gibbs equation. Delta G is equal to delta H minus T delta S. Based on that particular equation, you will get more numerical problems, right? Okay, tomorrow in the next session, I will be coming back with the third law of thermodynamics along with few parts of thermochemistry. You will be discussing about more numerical problems there. Okay. Now there is a general reminder about the All India test series. I hope all have already enrolled in the particular AITS. Then also I am getting a reminder just like that. You will get a discount of 2,999 by using the U250 off. So don't miss it. Anyway, thank you so much all of you. I will be coming back in the next class with the third law of thermodynamics. So far we will be, I hope I will complete this particular chapter thermodynamics in the next class itself. Anyway, thank you so much. Bye bye, take care. Then don't forget to subscribe our channel. Do like, share this particular session to your friends. Thank you so much.